In the previous video, we looked at how we can search for a pattern within a string of information. In this video, we're going to look at how we can work on the information that we match. So given that we have a regular expression that we can use to search through a sequence of characters, then we can have, as a result of that search, an object returned which has some information within it that we can use in a useful way. And that's what we're going to do here. Now, what we're looking at is what we call a match object. So once we have a successful search, that is, we actually found a pattern within a string, then the Python system is going to return what we call a match object. And we saw earlier that that object is going to be either evaluated as true or false, because we saw that with the if statement. But we can also query that match object to determine certain things. Now, when we looked at the search capability in the previous video, then we just had the regular expression .search, and we had that within an if statement. We can also save the result of that search in some variable. And here, just in a comment, I'm showing you how we can do that. So following along with the textbook, I'm just going to use the variable m, and then when we do a search given a pattern and a string, then whatever object, that match object, whatever that is, it will be contained in the variable m. To get started, let's go ahead and look at some examples. And if you have the book Python for Biologists by Martin Jones, then it will be on page 161. So I'm going to take these examples from the book, but I'm also going to add some additional examples as we go through this. Now, let's do what we call a group. We're going to extract a group. And I'm just going to have several examples, so I'm just going to call these example 1, 2, 3, and 4 as we go through the list. To have something to search on, then we have the string, the DNA string here that I'm highlighting. Now, notice in this DNA string, we have an extra non-base character in there, so the letter N shows up. So watch for that. Now, let's go ahead and let's add a case here so we can investigate how we can handle this match object. So the problem I want to do is this. Let's paste in the comments here. So within the DNA sequence, I want to do a search for a G, which is followed by at least one A. It could be more than one, but it has at least one A afterwards. So this group method will get the part of the string that match the pattern. So let's just go ahead and let's do the search. So we'll put the code here to do the search. Okay, enter. And notice I have the assignment statement here. All right, so I'm doing the same regular expression search that we did already, and I'm going to save the result in the variable m. Okay, so that's what I said I would do up here. And the string is going to be the DNA string, so that's the one defined there. And here's the search. So this is going to be a raw string, as we saw, and I'm going to look for the letter G, followed by the letter A, and the curly braces with the 2 there mean that I'm looking for exactly 2 A's. So I'm looking for the pattern G, A, A. All right. So in this case, I'm not quite following my my comment up here. Okay, so let's fix that a little bit. Okay, I'm going to search for G followed by, let's just do it uppercase A here, AA. All right, so that's what I'm really looking for. So my comment was off a little bit. Then, sure enough, is it in the string? Well, yeah, here we go. Here's GAA. So it is in there. Then let's print it out. So if I just print out the value for M, then we will see what we get. Okay, so we'll print this out. Now, as it turns out, in this instance, if I'm just referencing this thing called a group, then it's going to return the string that is matched. So it's going to return GAA. Now, let's go ahead and run the program so that we can actually prove that. So we'll see the output window pop up, and I'll bring it over here. And then here is the output. Okay, so we see here we have example 1, and then the output from this print statement, m.group, gives me the string that matched, so GAA. All right, so the match object in this case, the match object that was returned when I did the search is just the string GAA. Now, let's look at the example that came out of the book. So the previous example was one I just made up. So let's put the other example in. And this came directly from this page 61, all right? So this search is going to also search through the DNA string. It'll save the match object here in M. But this time, do you remember how we are searching? What are we searching for here? In this case, it might be a little confusing because I have this circumflex showing up here, and we know that that could represent the beginning of the string. But since we have it inside these curly braces, I'm sorry, the square braces, then it does not in this case. So this is a little bit tricky. What this is saying is look for any character that is not an A, a T, a G, or a C. So in this syntax, that circumflex is the negation operator. So it's anything other than A, T, G, C that we find within the string DNA. So in this case, of course, everything that's in the string is an A, T, G, C except that letter N. So that's what this will do. It will find that letter N, and then we will print out the group. So let's run the program and let's see what we get. So I'll run it, and we'll bring the window over, and then here it is. Okay, so we see that we do get the letter N. So that letter N was matched by this search that you see right here. Okay, we're searching the string for anything other than an A, T, G, or C. And then when I print out the .group method that we use on the match object, then we get the string that matched, which was just the letter N. Okay, so let me say a little bit more about this. I'm not sure I mentioned group enough. When we do a search, then we would get a match object that's returned. Okay, so the match object is saved here. Then we can operate on that match object with the group method. Okay, so group is another method in the same way that search is a method. But group operates on the match object, the thing that's returned by the search. Okay, now let's move on and look at another example. Oh, actually, I hadn't finished this example, so let's go ahead and include the rest of the code from the textbook example. And here it is. So after we do the search for anything other than ATGC, then we print out the group, and then we have the if statement here. Okay, so it's possible that the search doesn't find anything. So if the search doesn't find the string, then it returns a match object that evaluates to false. And that's why we have the if statement here. Okay, so we only want to print this out if we get a true result. If we didn't find the string, then there's nothing to print out. So we have if M, in which this case will be true, then we'll print out we have this ambiguous base found, which is the letter N. And in the example, then from the textbook, then that returned string, that match object is, the group operation on the match object. Let me try to get my English correct here. When we do the group method on the match object, then we save what it finds, and we save it here in this variable called ambig, and then we print that out. Okay, so this is the same thing that we did up here. We just printed out the m.group, but this is a bit more formal. We want to make sure that, yes, we did get something back, we did get a match, and then we're going to print out, hey, we found something in the string that wasn't a regular base, and then we're going to save it. Okay, we're going to save the group method that operates on the match object in the variable mbig, and then we'll print it out here. Okay, but that's equivalent to just printing out m.group by itself. We just use an extra variable. Okay, now let's run this, and let's look at the output that we get. So I click run, I click OK, we'll save it, and then the output crops up, and I got the huge window this time. But let me make that smaller. Let's shrink it down so I can get it on screen here. So then the if statement is going to print out the bottom two lines here that we found an ambiguous base, so M turned out to be true. We did find something. And then when we print that out, it just prints out the value N. So that comes from this last statement here. Okay, now let's look at another example. Now in the previous example, we just found one group. If we have multiple matches, then we can get multiple groups. So let's look at this other example, and again, I'm going to add one of my own examples to begin with. All right, so I'm going to get some code to do that. I'm going to just bring that over. I'll copy it, I'll paste it. And this is my example. It's not from the book. So this is example number 2. And here's my search. All right, so let's look at the search. We have, it's pretty long, but let's see if we can remember the notation and find out exactly what we're searching for. Okay, so we have the raw string, and then inside the double quotes, then I've got a parentheses here and a parentheses there. So that's one group that I'm searching for. Okay, so within that, I'm looking for the letter G and the letter A, which can have either one or two A's. Okay, so with the curly braces, remember, then you can put in a range. So I want a G followed by one or two A's. That's the first match I'm looking for. Followed by a C, and then G followed again by either one or two A's. Okay, now let's look at the D and A string, and let's see if there's something there that matches. Okay, I'm going to copy this and paste it closer to our example so we can see it easier. So here's the D and A string. Okay, so here's GA right there, but so that would match the first part, right? We have a G and we have an A, but I want to look for a C next. Okay, so there's no C after the GA down here, so the whole thing isn't going to match. But let's look up here. Go further along. So here's a G and one A and two A's, followed by a C. Okay, so that matches this part. We have a G and we have two A's, so that matches. Then we have the letter C. Is there a GA or GAA after that? And yeah, there is. There's a GA. So I should match the string. And this match object now is going to contain two groups. One group that matches, the first part, and one group to match the second part. So then I can print those things out. All right? Well, how do you print out multiple objects? Let's look. If we use a subscript within parentheses, then we can print out the multiple objects when we have them. So I'm going to print out group index 1 instead of just using empty parens here. So that will match, or that will show me what was matched by this first part of the expression here, and group number 2 will give me what's matched by the second thing in parentheses. Okay, so the things delineated by parentheses here are going to be the different groups that are returned. Great. Okay, so it's starting to get a little bit more involved. So let's run the program and let's just see what we get from this example. Okay, so we'll click Run. Okay, and here is the output that we get. All right, so we're down here. We're at example number 2, and you see we do get GAA, and then we get GA. All right, so the GAA was matched here in that first test. Okay, the GA1, 2, so that matched here. And then the second match is just matching the GA over there. And then we print those things out. So we have multiple groups that we can return from a search, and that's going to be part of our match object. Okay, now let's look at the example that was from the book, because I used my own. Now let's just go look at the one that came directly out of the textbook. So I'll paste that in here. And in this case, they just use a variable called scientific name and set it to the string Homo sapiens, and notice there's a space in there. And then we have the search that is going to show up here. So let me see. I think I'm missing the search part of that. Yes, I do have to do the search, so let's put that in here. And now let's examine the search. So here is the regular expression .search, or it means raw, but look at what we have. All right, so that's pretty abstract, isn't it? We have paren, left paren, dot, plus, right paren. What does that mean? All right, recall that a dot matches any character. And recall that plus means we have one or more of those characters. So this little thing here, that's going to match one or more characters, regardless of what they are. All right? So that's a broad case. It'll match anything, in other words. Then we have a space in here. That's part of the search. Okay? So we're looking for a string of characters there, followed by a space, followed by another string of characters, which can be anything. All right? Now, the string that we have up here was just Homo sapiens, and you can see that this will indeed match because there is a space right there. All right. So the first part of this first paren dot plus, that's going to match the first part of this, the homo. And then afterwards, we have the space, and the second match will be the word sapiens. And we're searching through the string, scientific name. We have the same if statement or similar if statement. So if we do get a match, if the match comes back as true, then we're going to set the genus to m.group1. So that's the first thing that matched. And the species, we'll set that to m.group2. And of course, that's the second thing over here. And then we'll print out genus is and species is here. All right, so let's now run the program and look at the output that we get. So here's the output, and you can see, let's fit it in here. All right, so in this last part, then we get genus is Homo and species is Sapiens. All right, so that is just another kind of unusual way, kind of cryptic, I guess you would say, of doing a search. Okay, so a dot matches anything, and we can have one or more of any character, and it will match. We just have to have two words with a space between them for this to work. Okay, now that illustrates how we can do multiple groups. Well, it's great to be able to match multiple groups, but we may also want to know where they appear within the string. So we can find out where those things occur. That is, we have a match, what position within the string does it occur? All right, so let's look at another example. And again, this is an example that I made up. So I'm going to put the code here, and let's examine it. So here we have example number 3, and I've just copied the DNA again and pasted it here. And here's my search. I'm going to look at the same thing I did up above, or something close to it anyway. I'm going to look for G followed by exactly 2 A's. Right? So this will match right here, G double A. Okay, remember, in the curly braces, you can put a range or just a fixed value. So in this case, it must be GAA. Great, so that will give me a match. Then I can print out where within the string that match occurs. So let's look at how we can do that. Okay, so let's paste the code here. And we can use the start and the end methods when we're working with a match object in the same way that we can use group. So now I'm showing you 3 different methods that we can use to act on a match object. So we have group, and we have start, and we have end. So if we really do get a match, and I'm assuming we do, I could actually put an if statement here to make sure, but I'll do that in the next example. But we can print out the starting location and the ending location of that match. Okay, so let's run the program and look at that. So the output pops up here, and we can see that the pattern GA2, which is GAA, it starts at 7, it ends at 10. All right, well, let's check that out. Okay, so here's the string over here. And if we go over 7, so 1, 2, 3, 4, 5, 6, 7 is right. Well, that didn't count right, did I? I disobeyed the law of computer science. We start counting at 0. Okay, 0, 1, 2, 3, 4, 5, 6, 7. So yes, the pattern GAA starts at position 7. And it ended at 10, right? Okay, 7, and this is 8, 9, 10. But by now you should know that with Python, that second number is going to be the next character after, not the one exactly where it ends. Okay, so that means if we have 7 through 10, then this is 7, 8, and 9. So that's what it means in Python. All right, so we now can determine exactly within that string where the pattern occurred. And given that, we can use some of our other operations, like the substring, in order to pull it out if we wanted to do that. All right, now, let's go on and look at the example from the textbook. So I'll paste it in next. And they're using the same search here that they did up above. And in this case, they're printing out, first they're using this, which technically I should have done. But if we do get a successful match, then we'll print out the ambiguous base was found. And remember, that's the letter N that shows up here. And this will print out where it is found. Okay, so we'll print out the start position. And since it's only one letter, then we don't need to print the ending position. So let's run the program and look at this output. So in this case, we see that we get the ambiguous base was found at position number 4. And again, if we look at the DNA and start counting correctly, 0, 1, 2, 3, 4, then this letter N shows up at position number 4. Okay, so now we're able to not only search for something, but we're able to then modify or to do some queries on the match object that we find. Well, what happens if we have multiple occurrences of something? What if we had, instead of just a single N in here, what if we had other N's or other letters that were scattered throughout where this match would occur? How do we handle that? Well, Python offers a way for us to do that, so let's investigate that. And it uses this method called findIter. That's iterative or iteration. So iterative find, that's what we're going to look at here. So this will be example number 4, and here's the string of DNA. And within it, you can see we do have multiple things that are not regular bases. So there's an N, and we have a Y over here, and there's an R in there. So this will find a multiples of the thing that we're looking for, not just one. So the find iterative, we just replace the search with it. Find iterative is one of the methods that we use from our regular expressions. So we're going to use it. And we're going just to look for GC within the string DNA. Okay, so how many of those were there? Okay, we see there's quite a few, right? There's a GC there, and here's a GC over here. Well, this will find all of them. And it will save them in the variable here that we're calling matches, right? So this is essentially more like the search method than it is a method working on the match object, because here we're doing the search itself. We're just doing a search where we're finding more than one thing. Then we can operate on this match object that shows up over here. So we're going to get a list of these then. Okay, so we have multiple occurrences of GC. All right, so how can we print those out? All right, well, we need to go through the list. All right, so let's paste in a little for loop here. And we're just going through a list the same way that you've seen before. So we're going to use the for loop for something in this list of things here. We're going to process all of them. So how many are there? Well, we don't know for sure. I didn't count them, but there will be several. So we're going to use now the group. So we've got the match object, right? So we have this returned here. And then we're going to pull out each of these match objects from this list of objects, and we're going to inspect it. So we're going to pick out the group. That's the matched string itself. And we're going to print out where it begins, and that'll be the position. So then we will print out the base, which is the thing we're looking for here, or in this case, there's, I guess, 2 bases, G and C, and where it occurred. And then we will also print out matches at the bottom. I don't really need that. Let's take that out, okay? Okay, so now let's run the program, and we'll go through it one more time, because it is quite, a little bit involved, maybe not quite involved. But here's the result that we get. Example number 4, an iterative search looking for GC. So you see we found 5 examples of GC in our DNA string up here. Okay, so let's check the positions. GC found at position 1. So we start counting 0 here, and then GC, okay, that's right there. So yeah, that's position number 1. And then we have another one at 11. All right, so let's see if I can count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So here it is again, okay? So there's a GC over there. So this finds all of them, and if we want to use the start method to find out the position, we can print that out too. So if you have a situation where you have multiple occurrences of a string that you want, then you can use the find iterative search instead of just regular search itself. And then we can use the method for group and start and other things that we might want to go through all of those matches. Okay, now let's look at this is my example, so let's look at the example that the textbook used. So let's bring it in and paste it down here. Okay, got to make sure that we don't have any indents that would cause problems. Now, the textbook is using the same search they did before. Look for anything that isn't an A, T, G, or C. So it will be looking for these characters like N and R that are in the list D and A. So it will return multiples, as we know. There are several in there. It will be saved in this list matches, and then we'll use the for loop to go through and print out the actual match itself, the pattern. That's the group, and we'll print out the position. So now let's run the program and look at the results that we get from that test. And here you see that they're shown down here. Okay, the first few of these that came from the first example, and then the second one is going to come from the search through the textbook example here. Okay, so N was found at position 5. And if we look at it and we can count 0, 1, 2, 3, 4, 5. So yes, okay, N was found at position 5. Then we have 6, 7, 8, 9, 10, 11, 12, 13, 14. So R is going to be at position 15. And there it is, okay? So here's just another example of how you can search through a string and determine multiple occurrences of a pattern. Let's look at another example. In this example, here's an alternate way to do the same thing. So this is, again, page 165 from the book if you have it. I'll print out example 5. Here's the same DNA string repeated here. All right, so I'm going to use my example first. So let's put that in here. And this is called find all. All right, so this is a shorter way of doing the same thing that I showed up above with the find iterative. In the case of find all, it's going to return a list. And we can print out a list as you've seen from earlier videos. It's easy to do. In my example, I'm going to look for an AT, or I'm going to look for an AT followed by a C or a T. So this will match ATC, it'll match ATT. Okay, so that's what this does. So an AT followed by a C or an AT followed by a T. So that will match several things in here, you can tell, right? We have an ATT there, there's an ATC, there's an then, well, that's going to be it. Okay, so ATCs and ATCs and ATTs are going to be in the list. All right, so now let's run the program and we'll see what we get. So this time, let's look at the list that comes back. And you can see it's printed out in list notation. So we have the square brackets on the ends, and inside the list items are shown in parentheses. All right, so the things that we matched. Well, we matched an AT. And I don't think I maybe described that exactly correct. I'm looking for an AT as one of my searches. Then I'm looking for a C or a T. All right. So let's look at the matches that we did get. We'll come back output. So here are the matches that we found. And this is going to find all of them. So we found an AT and a T. So that started out here, AT with a T. Okay, then we found an AT followed by a C. So we have one of those in there. Okay, AT followed by a C right there. And we found another AT followed by a T somewhere else. So we had 3 things that we found. All right, so let's look at those again. We found an AT right there followed by a T. So that's the first thing that went into the list. Then I was looking for an AT that had a C. Okay, here's an ATA. That doesn't work, but ATC does work. Okay, so that's the second thing we got, the ATC right there. And then the last one, we found another AT followed by a T. So here is AT, and it's followed by a T. So in searching through using find all, then this find all method created a list for us. So now we have the list, and once we have a list, we can do all sorts of operations on that list. Now let's look at the last example, which does come from the book. So I'll paste the code in for that. So here we're using the find all method again. Okay, so here we have find all, and here's the search that I'm looking for. So we're kind of replacing the search with different things. Okay, so we've been using search before, but you can see now we can do the find iterative version, so that kind of takes the place of a search. And we can do a find all. That takes the place of a search as well. So these are the search parts of the thing that we're looking for. And we will get something back from that match object that we talked about earlier. And in this case, it's going to be a string. All right, so we're going to look through the DNA sequence, and we're looking for a T, and then we have 6 over here. So we're looking for an A or a T, and this means that we want at least 6 or more. Okay, so with the Python notation with a range, you can leave off something to the right, and that would indicate that we want to go to as many possible letters that we could here. So it could go from, it could be 6 to 8, 6 to 10, and this, by leaving this out, it will be the maximum. So we can find the maximum number of things that have at least 6 of them, right? So we will look for sequences of A's and T's that are at least 6 letters long, and then we'll print those out. Well, we have quite a few to choose from up here. The first sequence shows up here, A, T, T, A, and all that. So we can, it will pull out all of those. So we have 6, we'll see, 1, 2, 3, 4, 5, actually 7 of them. So that'll match. We have 6 or more of those here. And then there's a T and A. Well, that's not 6. That's not long enough. And here we have A's and T's, and we have quite a few of those that show up. Okay, so 3, 4, 5, 6, 7, 8 over here. So we're going to match those 2 strings. So let's run the program and look at the output. So we'll bring the output over. And here's the list that we get from that last thing. All right, so with the find all, we want to have 6 or more of a strings or a pattern involving A's and T's. Okay, so that's the first one, and I just went over that. So sure enough, there it is. It's got 7, 4, 3, 4, 5, 6, 7. And this one, 3, 4, 5, 6, 7, 8. So we can use the find all to find multiple groups within a string, and then we can have those extracted and saved into a list. All right, so that's how that works. Okay, so as you can tell, if you're going to use regular expressions, then it opens up a really vast array of analysis capabilities that you can have when you're dealing with string-type data. So we can look for strings within a sequence. We can look for patterns. I keep saying that wrong. We can look for patterns within a sequence of characters that form a string. And, this could be in a text document where we might want to extract out something that looks like an email address or something that looks like a phone number. So we could go through a document and we could use these pattern matching techniques to extract information from those documents. And we can do it by writing a very small amount of Python code. And this is very common. It's a very common use of the Python language to do analysis of strings, paragraphs, pages, you name it. All right, well, I think that will do it for now, and we will conclude this video and stop the, we'll conclude the video and we'll stop here. How's that? So goodbye, everybody.